Well, hello there, everybody, and welcome back to the bench. After a long, crazy day at work, I just thought maybe I'd look at a small project for once after all the big things I've been working on. And this is another radio I bought in that lot of radios that I got from the antique store that was closing down. And it is a Westinghouse, and the thing I like about it is you notice it has the civil defense marking on AM broadcast, and it also has a shortwave band on it, so it's kind of a neat little radio. Now, I've not tried to turn it on. I have no idea if it works. You're seeing it just as I picked it up. It does have some cracks in the plastic, but all in all, other than needing cleaned, it looks to be in relatively good condition. Although I've not taken it apart, I have no idea what what kind of secrets this thing holds inside. But let's take it apart and see if we can put some batteries in it and at least see if it is even somewhat functional. All right, you all have to check out how cool this thing is to take apart. So if you look on the sides, there are these little buttons, one here and one here. And all you do to take it apart is you push the two buttons in, and the whole thing just hinges open, and there it is. Now, when you look inside, this looks like a long wire antenna and one of those, what are they called, fan stock clips or something. I know I'm butchering that word, but it comes with a long wire antenna for the AM, and probably the shortwave would be the whip antenna on there. And you can see that the battery clip is badly damaged. A couple other neat things here is, let me zoom you in a little bit. Look at these neat looking transistors. Little oval can. Those are actual transistors. Obviously they're probably going to be germanium, I would think anyways, with the age of this. But I'm going to, since this is just destroyed beyond repair, I'm going to just clip this out, and we're going to just go ahead and wire, just connect the wires to my little power supply, and we'll go from there. So let me do that, and let's see if we can get some noise out of this thing. Okay, so I just printed this out real quick, which is the schematic for this radio. And a really interesting thing here is the way that they're powering it. So let me zoom in a little bit. And if you look down here, there's actually 6 C-type batteries that power this thing. And the way they're wired in is it's like a split power supply. So you have your positive, which is ground. This is actually a positive ground radio. So you can see the positive of the first 4.5 volts, which is 3 C cells, is going through the power switch to ground or to chassis. Then the center between the batteries goes to the negative side of the speaker, and then you have the negative terminal from the other 4.5 volts of the battery there going to the other part of the switch, which goes to your negative power supply. And of course these are all PNP, I would imagine germanium transistors. And we can kind of look at the bias and everything. If you look at the voltages, I would have to say that these are definitely going to be germaniums. So anyways, you can see it has it's kind of an interesting circuit the way it works. So let's hook the power up according to this, and then we'll go over some of this here in a little bit and see if the thing turns on. So you can see I have my 3 wires connected. And in order to do this, if you're going to use an external power supply like what I'm using up here, let's see if I can, there's a bunch of wires hanging over it. But if you look over here, here's the power supply we're using. And I'll turn it on. And this one can actually do what's called, this is a dual channel power supply. So there's essentially two power supplies in one on this. And you can run them independent of one another. You could run them in what's called series mode or parallel mode. I have this switched into series mode, and what that means is you have a positive voltage here. The positive and negative terminals of the two power supplies are internally now connected to one another, and then your negative power supply is here. So you have a negative voltage from here to here, and you have a positive voltage from here to here, and with this in the center. So I have 4.5 volts or 4.6 volts on each power supply. So from here to here will be 9.2 volts, and from here to here and here to here will be 4.5 volts. Okay, so you have to have a power supply capable of doing that, or you will need two separate power supplies in order to power this radio up properly. There's some other ways you could probably do it, but that's the easiest if you have a dual channel power supply. So let's get back down to our radio here. And now that we have the power turned on, let's see if it works. I'm hearing some hiss. And that's not getting much else. So let's let this run a little bit. Nope, nothing. Now when I first hooked up this little power supply, turned it on, it did this, and all of a sudden it popped on and started running. And yeah, here it comes. How about that? Now, I have the volume turned all the way up, and it's not very loud. So, very strange. I mean, the radio, almost like it's warming up. And what I think is happening is I think some of the electrolytic capacitors in here are going bad, and as they reform, it lets the voltage comes up and the radio comes on. Or we could have a bad transistor somewhere. Like I said, it can be any number of things. But the radio does work. You can hear. And it's pretty sensitive, considering I'm down here in the basement and it's just got the little bar antenna inside.
The radio, those guys sound great, and I put them on once in a while, and they were on top of their game.
So I think if we get this thing working, it's going to be a really nice radio.
Bill on State Route 14, about 1.5 miles or 2 miles from Walmart at Sales. Can't miss us out in the country.
Okay.
Is absolutely stunning to me, especially when you look back at the...
So I'm thinking there's definitely going to need a recap, if nothing else. Again, looking at the schematic, let me get zoomed in here. Hold on. All right, so this is actually a really good design of radio, and it's a little bit unique. If we look at the front end here, you have your external antenna, which was that long wire that was included with the radio. And this actually came with the radio. I mean, you can see it has the little wire ferrule on the end. And that's the long wire for shortwave. And then you also have the telescopic whip antenna that we saw up there by the handle. And those are for your shortwave. And if you see, the shortwave goes directly into the mixer, and down here is your oscillator section to create your intermediate, your beat frequency to make your IF. And then you go through your first IF transformer and your first IF amp, second IF, you have a diode detector, and then you have your first audio and second audio, and then you actually have a matched pair output set. So it's a really neat little setup. And you have a transformer coupled amplifier, and that's how you're getting your phase shift. And this is probably, I guess you could call this kind of a quasi-complementary circuit. And then the neat thing is when you switch into AM, which they're calling it broadcast band, BC, broadcast band, if you look, actually has its own little RF amplifier. So you actually have an RF stage on this radio. So it should be a really good performing radio once we get it all set up. Again, circuitry is fairly simple. You have your shortwave and broadcast oscillator trim separate for your alignment. And then you have your IF amplifiers, which are all kind of, they're shared between shortwave and AM. So yeah, this should be pretty cool. So the first thing I think we're going to do is we're going to get this thing apart and look at this 100 microfarad capacitor. Look at this little 5 microfarad capacitor. Any of the electrolytics in here, if they're dried out and leaky, that would obviously cause some problems. Here's another one here. Another one here. So we have quite a few electrolytics in here that may or may not be bad. So we'll give them all a test. And hopefully we won't have to replace those transistors, because I'm sure those ones will be difficult to find. I know that some of the other YouTubers out there that work on these radios have had some success purchasing the Russian surplus germanium transistors. I do have some germaniums that are old, new old stock, but I don't know if I have any that'll work for these specs. I'll have to look them up. But let's get it apart and let's at least check the capacitors and check all the resistors and everything and do that first. I have the radio out of the chassis now, and you can see it's in pretty good condition all in all. It has been worked on though. Everything, all the components look original. It's very dusty, as you can see, but this orange wire, you can see, is kind of twisted together, and I do not know what that purpose of that orange wire is. It certainly doesn't belong in there. And if you look at it, it kind of, well, let's see if we can get a little flashlight in there. If you look down in there, you can kind of see right in there where it like wraps around that one piece of wire, and then it attaches, and you can see the giant solder ball right there, and it's looks like somebody just kind of gobbed that wire onto there. So I don't know what the purpose for that is, but we're gonna try to look at the schematics and figure that out. Other than a cleaning job, you can see here's the 100 microfarad electrolytic right here, and right over here is the 75 microfarad, and I think there's another one down in here. And again, I'm not sure what they're like, but we're going to take our ESR meter and just kind of check them and see what they look like. Well, these 5 capacitors were all bad. All the rest of them in there were good, and because they were ceramic, but these ones were really, really bad. This one, the 100 microfarad at 10 volts, it was reading a kind of high, which when they go bad, sometimes they read high, and it had high leakage on it. So, but it was actually still somewhat working. This one was completely gone. It was reading, I don't think it was 75 microfarads. It was reading 0. And if you look at where it's located on the schematic, right there, that's your bypass capacitor for the second audio. No wonder there was no volume in the amplifier, because it was like essentially taking this cap right out of the circuit. These two little 5 microfarads, once again, one of them is your coupling capacitor to your first audio, if you look. And the second one down here is a filter capacitor going, or probably part of your what's it called, AGC circuit, AVC, and it's going right up into your first IF. Both of them were completely bad once again, and this is supposed to be a 0.02 microfarad, a little paper cap, and it was just reading in picofarads, a few picofarads. So these were all bad, and I'm hoping if we put this back together, that might be all we need to get it working. Now you can see I replaced the caps in here. There was that 100 microfarad. The 75, I didn't have a 75, so I just put another 100 in there, which should work just fine. The paper cap was right down in here. See it? I replaced it with that little Mylar cap. And then right over, where is it? Over here, you can just see it. There's one of the other 5 microfarads there, and the other 5 microfarad is right here. So there they are, all replaced. And I'm going to clean the controls while I'm in here. I'm going to sort out what the mystery wire is right here. And then once we get those things, we'll put it together and give it another try. All right, a little update here. The first thing was the orange wire. I cut it out, and it doesn't seem to matter at all. What I think it is, it's wired into the deck switch, and it's shorting to this junction. I'm not sure what part of the switch it's switching, or it's shorting, but it's tying into this point where the 82K and the 2.2K are. So I don't know if that is just, they're just jumpering this on because the switch was bad, but I cleaned the switch with deoxit and it seems to be working fine. Now if you notice, I also took the faceplate off because we still had an additional problem. It was still kind of doing that warm-up thing where you'd turn it on, and after about 30 seconds, it almost acted like a tube radio where it would have to warm up. And I noticed when I put my hand near this little transistor right here, which is your RF amplifier for the broadcast AM, the signal would get much stronger and it, pick up stations. And so I started looking into it a little more closely, and you can see the little transistor is kind of right down in there, just right there. And if I would touch it with my finger, the signal would get real strong. If I would take this freeze spray and just squirt a little bit on there, the signal would go away. And then if I would blow some heat in there, the radio would come back on. So it turned out to be this little transistor here, and if you look it up, I don't know if it'll focus. It is a SO65, I think it is. Yeah, SO65. Believe it or not, NTE actually has a crossover for this. It is a germanium PNP signal transistor. But, of course, I don't have one of those. So I dug through my, I do have a small inventory of new old stock germanium transistors. And I came up with this one here. A GE1. So that might tell you how old this transistor is. And it is an RF amplifier in the correct case with the correct pinout. It's PNP germanium. It has a very similar gain characteristic. This one, the gain I think was crossing over to something in the 60. It was a low gain transistor. So everything about it looked like it was going to be okay. So I popped one in there, and I left the leads really long at first. You can see how long those leads come. And turned the radio on. You can hear right away. And then those new capacitors, I have all kinds of volume now. And of course, I'm going to get all garbage. And I'm going to check the alignment on this, but I'll tell you, boy, this thing is sensitive. It is working so well. I don't think I'm going to touch the alignment. I mean, I'll check it, but I have a feeling it's just not going to be out. It's going to be right on, so I'm not going to play with it if it doesn't need it. So this was kind of an interesting little project to fix. And I think this is going to be a really, really high-end little radio once we get it moving here. So let me get it put back into the case. Let's check a little bit of I'll check some alignment things on it real quick. I'll hook up a signal generator. And if all is well, we're going to button it back up.
Y buena prensa, esta institución de los jesuitas en México está sacando un gran tiraje que lo podremos.
And yes, we are on shortwave. Even the shortwave's working, and I'm hooked up to my 43-foot vertical outside, just through a little piece of wire here on that fan stock connector. And you can hear, look how sensitive.
A donde ambos han viajado para proponer a la industria. No, we calculate the family size, location, education, quality.
To me, let him deny himself, take up his cross.
So you can see this is quite a radio here. Let's switch back over to AM broadcast.
I thought they would have won, but
So long and lots of volume now, as you can see. So the radio's perfect, and I think I'm going to leave this downstairs here, and I'm going to clear out a spot down here in the shop, and this will be my shop radio just to kind of listen to while I'm working. Just because of how sensitive it is. Great little radio. Now the only thing I do need to do is I'm not going to run it off my bench power supply all the time. I need to get 3 battery clips for 2C batteries, so that would be 6. I need 3 2-cell battery holders, so that would give me my 6 cells all together, and wire them up. Just have to order a couple of those off of old eBay or something, and yeah, this radio is perfect. I was kind of surprised, and I'll probably clean it up a little bit, but it really doesn't matter. But wow, what a nice little radio. If I ever see another one of these out there, I'm going to snap it right up, because this is great. All right, well, hope you like this short little video on this little repair of this radio. It is once again, it is a Westinghouse H-712P9. And hope you enjoyed the video here. If you did, give me a big thumbs up. Don't forget to like and subscribe. And as always, everybody, I wish you all peace, joy, happiness, and good health in your lives. And till next time, take care of yourselves, and we'll see you soon. Thanks a lot. Bye-bye.